Good morning, good morning, good morning, and a very warm welcome to yet another video podcast here on the War Bonds channel. If you're new to the channel and don't know who the heck I am, my name is Eric. I'm a locomotive engineer by profession, an avid model railroader, and a lifelong rail enthusiast. Today is video podcast number 7 of a series entitled Building a 1-inch Scale Santa Fe GP60M. Now, if you are new to the channel and you haven't seen any of the first 6 videos that I've presented so far, I would certainly encourage you to go back and take a look at the content so that you can be up to date on what I've been doing on this GP60M build, as well as how it relates to the content that I'm going to present in this video today. Now, today is a very good day because yesterday I had some major computer problems and it made it very difficult to get content shot, uploaded. I thought I even lost some of my content, but thankfully everything is great. So I got my friend Pepe Le Pew, and I've got my Quolfie here, so I'm all set to start the day. So dynamic brakes, what do they do? What's their function?
Conjunction, junction, what's your function?
Hooking up words and phrases and clauses.
Conjunction, junction, how's that function?
I got 3 favorite cars that get most of my job done.
Man, we haven't gotten started in this video and I'm already starting with the shenanigans. Terrible. Glad you like it, because if you didn't, you wouldn't be here following me on this journey, and we gotta have some fun. But hey, what better way to start this than with some conjunction junction? It's some classic schoolhouse rock. But anyway, I'm good for the moment. But in all seriousness, we're talking about dynamic brakes. Okay, so how do they work? In relationship to the rest of the locomotive, how do they interact? What is their function? And that's the serious question. Okay, so in order to understand that, we need to understand how the locomotive works as a whole. You see that train coming at you, and you hear all that noise, you see the smoke coming out of the stack. That big thing that you're hearing the noise coming from, is that what is actually propelling the locomotive? Is it like stepping on the gas in your car and you start moving? Is that how it works? The answer is no. The big thing that you're hearing is called a prime mover. Now, the prime mover's job is essentially to turn a shaft. That shaft is connected to an alternator, and that alternator sits between the prime mover and the back wall of the cab. So, when that prime mover is turning that shaft that's connected to the alternator, it allows that alternator to start producing electrical current. That electrical current is fed down below into what we call the traction motors. Now, a GP60M is a 4-axle locomotive. So on each axle, there's a traction motor. When that electricity is fed to those traction motors, that is what causes the locomotive to start in motion. That is what is actually propelling the locomotive. So it's not the prime mover itself. Now, when I'm running a train and I crack the throttle, okay, there's 8 notches on the throttle quadrant. So for each notch that I give it, up to 8, every notch is raising the RPMs of that prime mover. And of course, the faster it's going, the more current that's being produced by the alternator, therefore the more electricity that's being fed to the traction motors, and that's what begins to increase your speed. So that is basically how that part of the locomotive works. Now, where do the dynamic brakes come in? The dynamic brakes basically function, in layman's terms, it's almost kind of like the same concept of you're driving a stick shift car, let's say, and you downshift. Okay, the power that you were using earlier to propel the car is now being reversed. So now you're actually using that same amount of power as resistance to slow the locomotive down. Or in the case of having a train behind you, it's actually slowing things down. So instead of those axles turning free rolling, there's a resistance, and those traction motors cause a resistance with the axle. So it's almost essentially like you get somebody behind you, and probably my little boy is an example of this, but when he wants to throw a little fit and I say, okay, come on, we need to go. And I have to push him from behind, and he's trying to dig his feet into the floor, into the ground, because he's trying to resist me. Well, it's kind of the same concept. That resistance in the axles is kind of pushing back towards the train behind you. Now, dynamic brakes were initially designed for railroads that run in hilly or mountainous territory, because when you're going downhill, well, that resistance that the dynamic brakes cause is actually a very beneficial and efficient way to run a train. Because if you're going down a pretty steep grade, you really don't want to have to keep using the air brakes and the brake shoes and everything, because that causes more wear and tear on the equipment. Whereas the dynamic brakes are powerful enough that as you're going down that hill, it holds the train back. And for an engineer, it's a lot easier to operate that train. So now, as far as the dynamic brake portion of this locomotive that I'm building, okay, what does that have to do with anything? We've talked about the prime mover, we've talked about alternators, we talked about traction motors. So, what does that big dynamic brake box do? Okay, when you're in dynamic brake mode with the traction motors, the byproduct is it causes heat.
So on the left side of the locomotive is what's known as a traction motor blower housing, as we can see in the photo. And it does just what it says. It's a housing for a traction motor blower that actually takes the heat away from the traction motors, sends it up to the top through the dynamic brake grids, and disperses the heat. On the top of the dynamic brake housing is also a fan that also helps in blowing a lot of the heat out. So sometimes when you hear kind of a whine or kind of a growling sound, that's actually the sound of the fan in action as it's helping to dissipate the heat.
When you're operating a train going down mountainous territory, and I said that, yeah, the dynamics for the most part are strong enough to be able to hold the train, but it depends on how heavy the train is. Now, if you have a light train, the dynamics can do it. But if you're going down a mountain, with a heavy coal train or something, yeah, then dynamics aren't always going to hold you. So therefore, you have to supplement the braking effort with setting air and using your air brakes to help in conjunction with the dynamic brake. All right, so with all that said, I want to take you back to 1988. 1988 was a really cool time because my dad was not a rail fan, but he would actually go out with me and bring the video camera, and we would go out and shoot Santa Fe trains back in Galesburg, Illinois, where I grew up. And one of the things that I always noticed is that these trains always had a real distinctive sound. So we talked about prime movers, we talked about traction motors and everything. So I want to put up a couple videos, about 2 or 3 videos, that I want to explain some of the sounds that you're hearing. So let's go back to 1988 to the Santa Fe main line, the Chillicothe subdivision through Illinois. Man, I still get tingles looking at that stuff and remembering the things that I saw back in my teenage years. That was just some of the coolest stuff, but like I say, that was stuff I did with my dad. The footage, technology was not the greatest back then, but just to have those memories is just priceless to me. But the reason I wanted to show those 3 clips is, what do they all have in common? If you listen to every single one of those locomotive consists going by, you'd hear this real high-pitched whine. Those are the traction motors. And in those cases, in the case of all 3 of those trains, those were 3 wide-open 70-mile-an-hour intermodal trains. And that is the sound that you're hearing, that distinctive whine of the traction motors. So that's what I wanted to kind of add into the explanation that I gave about how everything works. Now, you could also see the smoke and still hear the rumble of the prime mover. That's how everything works together on a locomotive, hence why they're actually called diesel electric locomotives. Hopefully, so far, you've learned things that you didn't know about how diesel locomotives work and get a few extra ideas, at least from my take and my perspective on things. However, in this next clip, I want to show you a GP60M. Well, actually, it's now technically called a GP60M-3, but they're kind of rare in the Midwest because they're all being held captive in California for the most part, but we have one running around here. And a friend of mine, Mark, another colleague of mine, had told me that this particular local was coming through with this GP60M. So I went out with my son and we captured it as it was going into the siding. And if you listen carefully, you can kind of hear the sound of the dynamic brakes. Now, the engineer was actually using the dynamics to kind of control his speed. Now, I mentioned mountain grades, but dynamic brakes can be used in all sorts of territories where you can even use them on flats if you want to try to slow your train down without using the air brakes, which is actually what the railroads prefer, as your primary brake is using the dynamics. So if you listen to this next clip of GP60M-3 coming into a siding, you can kind of hear a little kind of a growling sound, and that's the fan of the dynamic brake unit that's helping and dissipating all that heat. So if you listen carefully, you can hear that. You're still here. Well, I'm glad to have you along, and I'm glad that you've stuck with me on this journey. I hope the content that I've presented in this video podcast number 7 has so far been very interesting and beneficial to you. So as rail fans, I like to present things to you that maybe you don't always understand, or why does this locomotive sound like this, or what is this, or what is that? I like to try to answer those questions, and especially as I'm building this locomotive, I like to give you a little bit more of an insight of certain components and things that I'm building so that, this is what it actually does, other than just like, yeah, I'm just putting this on the locomotive and doing this and doing that. Now, this isn't a how-to guide of how to build your GP60M, because I'm sure that most of you, if any of you, will ever build one, but obviously there is that maybe 1 or 2% that might try to attempt it. And if I can give any kind of information to help you in your journey, that's wonderful. That's great, because that's what this channel is all about. So the next part that we're going to present in this video podcast is the content of me starting the actual dynamic brake work. So join me in my driveway about 2-3 weeks ago when I started doing some work with the dynamic brakes on the GP60M. So today what we're going to talk about is the dynamic brake section of the locomotive. Now, in video podcast number 4, my friend Justin graciously gave of his time to help me in welding the frame to the deck of the locomotive, and we've got more of a permanent fix on that right now. So things are really cooking along a little bit better than I thought they would be at this point. So one of the other things that we tried to do some welding with was the dynamic brake section. However, one of the problems that we ran into was the fact that, unfortunately, with this design, some of the parts are a little flimsy, and the welds just didn't go together very well. And let me come up to the camera here and show you a little bit of a close-up here. But yeah, we had some things that didn't quite go together very well, and yeah, some of the parts there just didn't hold very straight, and yeah, you can kind of see how that happened. So unfortunately, yeah, it didn't work, and we can't let that go like that. So what I've decided to do is to rebuild the sections, the dynamic brake boxes, or grid boxes, if you will. And as I mentioned, I think maybe in podcast number 1, that I had tried to do a GP60 in styrene plastic. And even though that project didn't work, I still have some of the parts from that model attempt. So what I'm actually using here is a mock-up of what my original design was going to be for this, for the dynamic brakes when I was making my first attempt at it. So I'm actually going to use this mock-up as a way to try to maybe see if I can redesign it so that things work a little better. Now, in this case, it's a solid box. In this case here, we have actually made a contour there so that it was designed so that it contours to the curve of the roof line. But since things aren't working out, I'm going to do something that I don't really know that I want to do, but I'm just going to use aluminum and try to cut it out and pretty much fabricate it just like I would do a styrene plastic mock-up. But I'm probably going to end up using JB Weld and try to see if we can get it together. But at this point, I don't really know what else I can do right now. And, you know, as I say, as I go along every day, things can change on a daily basis. But for what I'm trying to do right now, it seems to be the best option. So who knows, by the end of this video, it may be one of the best decisions I made. It may be one of the worst decisions I made. But that's why I document these things, so that you can see that not everything works exactly the way you want it. But nonetheless, what I'm going to end up doing here is I'm going to put this piece here on the roof line here. And then I just want to fit it there so that I can draw a line on both sides so that I can get an idea of how much I need to notch out of this piece in order to be able to fit a box in there. So that's what we're going to try to do today. So we're going to get started here. Okay, so we're got this dynamic brake blister positioned over here on this side here. So we're just going to take a Sharpie here. Okay, we got that side there. Okay. Make sure everything is sitting firm here. Okay, and so we got our 2 lines on here, so this is what we're going to start off with. I'm still going to go back and do a little bit more measuring because I said, you know, these parts, you know, the way it went together was a little inferior here, but even if nothing else, if my lines are just a little off, at least it kind of gives me a starting point for the measurements here, so I can go back and measure, make sure that we have a very parallel line to the length of this piece here, and then we'll go ahead and draw in the perpendicular lines for the next cut. Okay, so what we're going to do here, we're going to take the dynamic brake roof section here, and I'm going to use this piece. Now, granted, it is an inferior piece, but I at least just want to get just a little bit of an idea as to how far in we need to go, because we are going to notch this out in order to be able to put a box in here. So I at least just want to kind of get a ballpark idea here. So we're just going to make a couple marks here, and then that kind of gives me an idea. These parts are not squared, so therefore we're not going to try to even attempt to use them, but like I said, we're just making a couple marks so that I can take the tape measure here, and just to get an idea of how deep we need to go in here. Okay, so it looks like we're going to go just a hair over 3/4 of an inch that we're going to have to cut in here. Let's see. Yep, so that's what's going to be our mark for both sides here. So I'll do some draw some lines here to make sure that we get the lines straight, and then we'll take a cutting wheel and get started. So I made the measurements in where I wanted. And took the Sharpie marker to make a mark on one end, and then make the same measurement on the other end. Well, then I actually took my mock-up, because it is actually a well-made piece and has a straight edge. So then I just lined up my marks and then used the Sharpie in order to make the lines. And we did this on both sides here. Okay, so I have even lines on both sides. So at this point, then I can start the cutting here. So because I'm not a metal guy, I'm probably going to use some slightly inferior methods here to do my cutting, but thankfully my mechanic friend LJ actually loaned me a cutting wheel, since he's an automotive guy, so I should be able to at least get started making the cuts. So I'll try to do the best I can to show how I'm gonna make the cuts and do all this. Okay, so as you can see, I've changed my eyewear here. I'm actually putting on a pair of safety glasses that I would actually normally use for work. So I have an old blade here in my table saw here, and maybe not necessarily the best way to do things, but you know, I'm working with what I've got here. So we're going to just carefully make the perpendicular cut. So I'm going to have to do it on one side here and on the ends here, and then I'll end up turning it around and making yet another cut. Okay, so we got one cut there. Now, theoretically, I just need to turn this over and try to get into another cut, but I can't really see my marks, so we're just gonna take our time and do this. So this just gives you an idea of how I'm getting this started here, but I'll turn off the camera for now, and then I'll show you the end result here once all the cuts are made. Okay, so we've got the notches, at least the majority of it, cut out there. So we just need to go in and do a little touch-up cutting and grinding down here. I went in a little shallow on some areas just because I didn't want to take a chance on cutting too deep, because this isn't something like a plastic model where you mess up and, oh, I can always refabricate another one. So we've got to be very, very careful in everything we're doing here. But we're going to clean this up and then show you the finished product. Okay, so after probably about a good little over an hour working on this, we finally got this roof hatch notched out. So as you can see there. So now, granted, my mock-up was actually a little bit long, but you know, nonetheless, I mean, you know, just kind of gives you a little bit of an idea, you know, how everything is going to fit in. But of course, I'm going to be fabricating the new parts out of aluminum. So, so far so good. So we'll see how everything comes together. But sorry I didn't do more camera work with this, but I'm not going to lie, I was a little nervous because I only have one shot at this, and you know, mistakes could easily be made, but I tried to at least show a little bit of what was going on. So of course, this is the end result here. So I'm quite satisfied, and the project is still going strong. So I still have a few burrs to sand off here, but otherwise everything is looking good. So the next step will be trying to cut out the pieces for the grid boxes, and we'll see how that goes. Well, we've seen the start of the work on the dynamic brake section, and you've also gotten a little bit longer of a lesson than I was intending to give on how a locomotive works, but nonetheless, I hope it was beneficial in understanding what the real thing is all about when you see those components on the model. Now, because of the fact that I ran a little long with some of the stuff that I wanted to discuss, I'm going to end this video here, and I'm going to make a part 2. One of the other things that I wanted to also mention that you will be seeing in the part 2, which is now going to be video podcast number 8, is I initially said I was going to be using aluminum parts in order to fabricate the dynamic brake boxes. However, the aluminum material that I acquired started to look really, really thin, and I started to have a lot of second thoughts that this is not going to work. There are things that are going to be somewhat delicate anyway, but no, this was going to be a little too thin for my liking. But I wanted something that was thin enough for me to be able to cut on the bandsaw, because that's the only saw that I can use to really cut the material that I need without totally chewing it up like the table saw would do. But like I said, it was too thin, so I ended up switching to K&S Brass. K&S is a brand of brass strips and sheets that's sold at Ace Hardware stores, at least in my neck of the woods here. But that's what I ended up using, and it ended up coming out really well, and the brass that I used was 32 thousandths, so it was actually pretty thick and well versed for what I needed to do. So when we start in the video podcast number 8, which will be part 2 of the dynamic brake work, you'll see the work that I've done and you'll see the material that I've used. So I hope that this has been entertaining for you, and I look forward to seeing you in the next video. If you would, please like and subscribe if you enjoyed this content. Thank you very much. I appreciate you following me on this journey. See you in the next video.